Alright, Crewton Ramone with a two-part screencast about a math enrichment session I did with, actually, it's homeschool tutoring, I don't know what you call it. Mostly math enrichment with a 7 and 8-year-old. We were having fun, and last week we did this, and it's still there on the board, as a algebra problem. And what we wound up there was counting x to the fourth, all these x to the thirds, 5x to the thirds, 9x squared, 7x, and 2, and then factoring it, and then factoring those factors and making them smaller and so forth. And then we changed from base x to base 10. So here we are at base 10, and they had to write it in their notebooks, and so we rewrote, recolored it over. And what we see here is 15,972 divided by 132. So the whole rectangle, let's see, it's bigger is just funner. All this is bigger, right? Up to 15,000. The whole rectangle is 15,972. One side is 132. So this side is 132. Please tell me the side that has the arrow, right? It's that side. And any little kid can see that's 121 if they've been playing with this system for a while. This wouldn't be day one, now would it? Right? But once we're used to the pieces and we know this was no big deal. In fact, they were all, two of them, were commenting that the algebra is actually easier. So anyway, there's the little girl drawing the picture in her notebook and making the symbols and so forth. And there's the little boy. And look at that, they're in pink and blue. How cute is that? Anyhow, so now we've done this. Like I said, this is all old hat. We did that last week. So now we're doing this where we're doing base 10 mathematics. So now they're going to have to tell me what the one side is, and then do all the work underneath. And then later on we're going to go back and do all the work underneath the algebra. But for now, just getting a good feel for what's going on. So across 132, down 121. And then we just modeled this and saw that, look, when I go across that 100, this one right there, I actually go across a 10,000, 3 1,000s, and 2 hundreds. There it is, right? And what's left is everything under that line. So all we had to do is count. And what's left is 2,772. And see, that just happens to be subtraction, doesn't it? But all we were doing is modeling and counting. We didn't need multiplication skills or subtraction skills to solve this problem. Just count. Just being able to count. We had to be able to count all the way to 9, so it was a big problem. And in order to solve this, we had to be able to count all the way to 7s. Right? So anyway, counting what's left is 2,000s, 700s, 7 10s, and 2 units. And then when I go across these 2, and those 2 are 20s, so it's 20 times this, right? It's not just 2 times that, which is what you'll hear a lot of kids verbalize in other systems or in public schools, and they'll actually just put arrows here instead of zeros so that they get even more confused, not understanding that that's actually 13,200. But anyway, the 20 multiplied by 132, there it is. In between these two lines is 2,640. Very simple, right? This times the 20. But all we did was count 2,640. Write it, and then count what was left down here. And what was left down here is 132. And the question always came up, why do we have to write the 132 twice? Well, because I haven't counted the 1 yet. So now I multiply 1 times that, and I get this. And you'll see that so much math goes on in the kids' minds when we do the bigger problems. All kinds of compound learning going on here between add-ins and subtraction and multiplication and factors and all kinds of fun stuff like that. So you definitely want to include this when you're working with little kids. Alright, there's the little girl's drawing of it and the symbols, and they're off, and we have to model this, right? This idea called putting them in a situation where they can't fail, but we also have to have control of error when we're directing their discovery. And we have error here because this is way off. They need to line up. And we talked about why they need to line up. And then as you see, she corrected as we went along, and by the time we got to here, these are all lined up nicely. Hundreds with the hundreds, tens with the tens, units with the units. And there's our drawing. Anyway, not bad, I'd say, for all of 8. So then after we stretched in that big problem, we did some small problems. So right there, 156, let's just do that and see what the symbols look like and how it works. So that's the little boy's book, or piece of paper that he was drawing on. And notice that he has it drawn for multiplication, not division. And notice that it's not 12 across, or excuse me, 13 across and 12 down. He's got a whole different problem here. Same blocks, but it's a big difference that this needs, so we, again, just direct the discovery and control the error. There it is. So now, got the change, so now we can see that, yes, it's 13 across and 12 down. See? And the whole rectangle is 156. And I got out 3 6s and talked about 3 6s, as usual. Should have had them here. But just 18, one side's 3, the other side's 6. And if I'm doing division, where does the 3 go and where does the 6 go, depending on how we have the blocks. So here, his picture now mirrors this picture. Oops. This picture now mirrors the actual blocks, right? The manipulatives. So now his symbols also mirror the correct picture, right? Or the manipulatives that we had. So you can see that it's 13 across is 13, 12 down. There's my 130 with 26 left. And when I go across those two, there's 26, right? So I have 26 left, and then I have to go across the 2. That's why the 26 shows up twice. Kids always ask that question, because when they're doing it, all they're doing is counting and patterning. So out come our friends the dinosaurs, and now they're looking at an even easier problem. This dinosaur is going to tell us the whole problem. You can't really see from this angle, but his head can look over, and this guy's head can't see over the top. It's lower than the block here. So he tells us 132 and one side is 11. This guy tells us what the other side is and has to make notes. So when he does that, okay, well, I don't have the pictures of notes there, but anyway, that was the next problem. Then we did another problem, even harder, that the students actually built for themselves, where the whole thing is 228, one side's 19, what's the other side? 12. And then we did the work underneath. And you can see there's the 190. When I multiply 10 times 19, I get 190, with 38 left, right? 2 18s there. And, or excuse me, 2 19s there. That gives me 38. And then when I subtract, I get nothing left. Do I have a picture of it? No, I don't. Okay, so now the dinosaur for sure can see that I have 165 there, and one side's 15, and this guy has to tell me what the other side is, and take notes, and make notes. So there's the quick drawing of it, and one side's 15, the other side's 11, and sure enough, 10 times 15 is 150. Right? We're just counting. One big red one, 5 blue ones. What's left is 1 and 5. And we have a name for 1 and 5. It's 15. And then when I go across this 1 right there, I go across 1 and 5 more, and there's none left. So that's why I have to count this twice. I count it once as left, and then once I use it up. And that's how I use my notes. And you can see the other kid spelled out his name there, and there is the, what do you call, the symbols, and he's got a nice picture there, and he's got everything all nicely lined up, notice, right? I said, control of error. And then we moved on to fractions, and I think I'm going to make that an entirely different screencast. So there is division. Very simple, very easy. Crewton Ramone's HouseOfMath.com for more. Quick lesson on division, and you know what? What the heck? I got 9 minutes. I can do it. I can fit it in there. Okay, so very quickly, we change the names of the blocks. We change it to, because using my imagination, I can do anything. Now this is a 1, and this is 1/3. So this is 1, and this is 1/3, and then I got some other bigger pieces out, so I could do the demonstration of, if this is 1, 2, 3, what do I have to take out of each one of these to get 1? Or what would I have to multiply this by to get 1? And the answer, of course, is 1/3. If I took a third out of this one, and a third out of this one, and a third out of this one, then I could put those 3/3 together and get 1 of these. Right? Kid could see that. So now I'm just saying, look, this is 1. This is my point of reference. I know what 1 is. 1 is this one. So this makes this 1 out of 3 instead of 1. Now this is 1, and this is, so then we did a 3-period lesson. Show me 1, show me 1/3, show me 2. Then we moved on to, okay, so if this is 1 and this is 1/3, show me 4/3. Well, there's 1, 2, 3, 4/3. And the kid said, you know, it'd be easier to just grab a 3 instead of grabbing these units. I said, you're right. And we could see that 4/3 was the same thing as 1 and 1/3. So let's do 7/3. Well, there they are, 2 and 1/3. Ah, see, we're counting by 3s. The kids get it when you do it this way. So there they saw, look, that's the same thing as 1 and 1/3. And look, no equal signs, no, right? We're moving along. And now pretty soon we see that 13/3, right? Man, if I had to count out units, that would take forever. But now that I can just grab this, 1, 2, 3, 4 of them, right? And now we start to see why it is that these mixed fractions turn into these numbers, right? And how we get improper fractions turn into mixed numbers. So now here's the next problem that they're going to do. 17/3. So here's the girl getting together 17/3, right? She was going to fool around with a bunch of these, but then the boy told her, look, it's just way faster if you just use these, and then whatever left over you need, you use the units. So she thought that was a good idea, and there it is. She lined them up, and we wind up 17/3 is the same thing as 1, 2, 3, 4, 5, right? The most 3s we get out of that, and 2 left over. And there's the drawings of them. And now you can see we're moving to the equal sign, that 17/3 is the same thing as 5 and 2/3. They really are the same. And there's the drawing of it, right? So here we actually see the progression from the concrete to the semi-abstract with the pictures and drawings, and then to the symbols. And so at that age it's a quick progression. And here we had a little problem because one of the kids still has difficulty making symbols correctly. So again, right, just control of error, or control the problem that she was having by just showing her, look, it's a big 5, and then we're 2 of the thirds. And she goes, oh, that makes sense, that's easy. Okay, so again, just because the kid can't make symbols and stuff doesn't mean they can't learn the concepts. Right? And if they're having trouble with the symbols, do it for them. And then just keep getting bigger, right? And the little boy, those are his symbols. So we got out 6, right? 1, 2, 3, 4, 5, 6 of them, and a third. Again, combo kit does everything. You don't have, I mean, it's great to have other parts, but you can teach all the concepts. And then, of course, quarters. We move on to the next piece. If this is 1, right, I use my imagination. Now this is 1. Instead of it being a 3, it's a 4. So now this is a quarter. And we talk about this being 1/4, and they're 1/4, and then we spent a long time, what else is another name? They couldn't think of it, so I actually got some quarters out. That's why we call these quarters, because it takes 4 of them to make $1. Oh! Right, and you can hear the light bulbs going off. So here's 1, right? And this is 1/4. We did a 3-period lesson. Show me 1, show me a quarter. What's this? So on. Alright, and then just for fun, right? And we're just to get, right, 9 fourths. What's that? Well, it's the same thing as 2 and 1/4. Right? So here are 4 fourths and another 4 fourths, and another fourth gives me 9 fourths, which gives me 1, 2, and 1/4. Super easy, super fun, easy for them to understand concepts in division. And see, that whole 90 minutes that we spent was on division concepts. And just so happens that we did big numbers and some, division of rectangles, but we also did fractions, right? How many of these are contained in here? And what we did was counting by 4s, actually, right? But actually, every time we get a quarter, right, 4 quarters together, that's a 1. And they really understand it when they can get their hands on it and play with the pieces. And then, of course, we're going to do 5ths and 6ths and 9ths and all kinds of pieces, right? But to start off, simple and easy. And then I gave them like 3 or 4 problems for homework. It would take them no time to do, and it's fun and simple. Crewton Ramone's House of Math.com for more.